Welcome to our pre-calculus lesson. This is our lesson 5. In this lesson, we will discuss even odd properties of trigonometric functions, periods of trigonometric functions, and then we will try to solve some maths to find out the exact values by using the unit circle, by using the circle and the fundamental identities. Of course, that circle is related to unit circle as well. So let's begin. These are our agenda, as we said. Determine the period of trigonometric functions, even odd properties, and then finding the exact value. We will discuss two methods. One is circle, another one is identities. So that's the task. Let's see. First of all, determine the period of trigonometric functions. So first question is, what is a period? What is that? Suppose instead of trigonometric functions, if we say the period of something, what does it mean? If something comes after a certain time, if anything comes back again and starts over, then we call it this is a periodic motion, periodic thing. Something is periodic. Suppose the year also, every December we see the similar kind of weather every December. So that means we call it the weather is a periodic thing, because after some certain period of time or after some certain distance we see the same thing again and again. Then we call it this thing has some periodic nature. And our sine function, cos function, tan function, they are actually they have the similar properties like the periodic thing in our daily life. Okay, so let's look at this. How can we explain it? This one is, if we look at this figure, you will see that this value, which is 5/3, that means 60 degree. So this is 60 degree. For 60 degree, on the unit circle, the value of cosine is this and the value of sine is this for 60 degree. So for 60 degree, cos 60 degree means 1/2, and cos sine 60 degree means root 3/2. The thing is, this is 60, but when you come back, this is 60. If you do the exact one rotation and then come back here, you again hit the same line, same point. That means same value also. That means 60 plus 360, 60 plus 360, you will get then again same value. And in the calculator also, you can check it. Suppose sine 60 degree value equals to 0.86, which means root 3/2. Then if we add 360 with this, you will see, I will write 360 plus 60. You will see the same answer will come. See, the same answer, 360 plus 60, same answer is coming. And now if I continue doing this, I will again get the same value. Same value, we will continue getting it. And same goes with the cos also. Cos 60 degree value is 1/2, and you will see that after every 360 plus this value, we will get the same value for cosine. So it means what? It means that this value resembles some periodic thing. After some certain period of angles, after some certain angle, we get the same value, same value, same value, same value, because actually we hit the same line. We hit the same line. That's why this kind of property, this kind of behavior is called the periodic property. And we can see that for sine and cosine. For sine and cosine, we can see that our period is 2 pi or 360 degree, because every 360 degree, after every 360 degree, we will get the same value of the functions. And how do we know that that thing? Because as you can see here, this is our 60. Then if you come back from here to up until here, again it is total 360, because from the same line we start and we come back to the same line, so it is 360. So at any line you can draw, then you will have the same thing. You will have the same thing wherever you draw it. So after 360 degree, we will hit the same line, exact same line. That's why we will get the same value. That's why we have our period of sine and cosine function is 2 pi or 360 degree, 2 pi. And we can summarize this whole thing. that is for sine function every 2 pi. Theta plus 2 pi means again that means sine theta, which means suppose theta is 30 degree, then 2 pi. 30 degree plus 2 pi means again just 30 degree, or 45 degree plus 2 pi, any degree, any angle you can put here, any angle you can put here. Sine and cosine, they will be similar. Sine and cosec, cos, sec, all of their period is 2 pi. Tan and cot, since tan means sine divided by cos, so we have the their period is pi. That means tan function, for tan function, after every 180 degree, the value starts repeating. The value starts repeating. Now, where we will use this periodic property, two examples are given here. This is 25 number from our section 6.3. How can we solve this math? Suppose how this periodic property helps us. See this. So our for the tan function, you see, for the tan function our period is pi. Period is pi. That means multiple of pi, for every multiple of pi we will have the same tan value. So you see, if we break it down, 19 pi divided by 6, if we break it down, we can write it this way. See, this is divided by 6 and something, we have to write something here. So you see 19, this is 19, then if I write 3 pi here to match with 19, we are just trying to match with 19 pi. We are trying to write a function, write a value here which will match this 19 pi. So you see pi by 6 plus 3 pi. So 3 into 6 means 18. So 18 pi plus pi means 19 pi. Why we are writing it like this? Because we are trying to use this periodic property. See how it helps us. This thing actually simplifies to very simple thing. So then we have 10. Since theta plus pi, theta plus this value equals to again tan theta, so we can just write the whole thing equals to just pi by 6. This whole thing equals to just pi by 6. Why we are not writing this thing? Because the value will repeat. So basically this thing is not necessary at all. This thing is not necessary at all. This is pi by 6, pi by 10, pi by 6 means tan 30 degree. The tan 30 degree value is 1 by root 3 or root 3 by 3, whichever you prefer to write. So according to our book, we will write root 3 by 3 because we have to rationalize the denominator, that's why. Now this one, 26 number. So for this 26 number, this is sec. Again, let's try to break it down in such a way so that we will have this value. So let's write 6 down here for easier calculation. And what can we write here? See, this is 6 and this is 25. And if we write here 4 pi, 4 into 6 means 24. So let's write here pi. Let's write here pi. So you see 24 plus pi equals to 25 pi. And this is 4 pi. So this is 4 pi means for sec theta, you can go to this function. This is the sec theta for the sec theta function. So 2 pi, then 2 into 1, 2 into 3, 2 into 2, any multiple of this actually will work the same way. Another way to write this thing is 2 pi then k. The value of k is any value. Suppose you can say, sir, why you said that this is 2 pi, has to be 2 pi, but why it is 4 pi? The k value can be anything. Okay, the value of k is anything. That's why it is called periodic. You can put any value here. It will not it will not change the value. The value will be same. The answer will be same. So and this is true for this line also. This is true for this line also. This is true for this line also. So this will be pi k. This will be pi into k. This will be 2 pi k. This will be 2 pi k. And the value of k can be anything. That's why the value of k is 3 here. Okay, it can be any value, any integer value. We have to say integer value. Why integer value? Because it can go to the negative side as well. So sec, this is sec pi by 4, pi by 6. And now sec pi by 6 equals to what? Sec pi by 6 means sec theta is related to cos theta, and we have to look for cos, this is pi by 6. Pi by 6 means 30 degrees. So cos 30 degree value is what? Cos 30 degree value means root 3 by 2. Cos 30 degree value, sine 30 degree value, sine 60 degree value is root 3 by 2. So cos 30 degree value is root 3 by 2. Root 3 by 2. So since root 3 by 2 is cos 30 degree value, this will be 2 by root 3. This will be 2 by root 3 because reciprocal. But root 3 downside root we cannot write, so we have to rationalize it. So we have to write it 2 root 3 divided by 3. So this will be our final answer. So the benefit of this periodic thing is it actually helps us to simplify the math easily. This is the main benefit of it. You have to you have to consider it for tan function and cot function, it is pi, and for everything else this is 2 pi. 2 pi is the period of that. Okay. So we will start our even odd properties. Just 30 seconds. I have to do a simple work. Yep, I'm back. So water was boiling too much. Yeah, I just gave the water to boil. Anyway, so even odd properties to find out the exact values. This is another concept. Just like the period, this is also another concept which we need to develop. Even odd properties to find out the exact values. You have some idea about the even function and odd function. I can tell you that because we have actually these things in our syllabus in our different levels. In level 2 also, I think in couple of sections we used it. Suppose y equal to x square, y equal to x cube. Suppose y equal to x square, what type of function it is? X cube, what type of function it is? If x equals to x square, if x equals to x cube, you have that concept. The same concept we will be applying here. Nothing new, nothing new. Just the thing is here it is about trigonometric functions. So if I ask you, what is the this is y equal to x square, is it even function or odd function? And y equals to, this is actually equation, I can write it function also. Let me write it in terms of function. Suppose if x equals to x square, this one, and then if x equals to x cube, is it even function or odd function? Let's refresh your let's refresh it. Actually this x square is even function, power 2 4 6, then it gives us even function, and the graph of even function is something this this is the graph of even function because it is symmetric with respect to y-axis. And the odd function, this one's graph is something like this, and the graph of odd function is symmetric with respect to origin. Odd function, even function is y, odd function is origin. So this is our previous concept, and same concept you will see we will be applying here. But before we go to this concept, just look at this picture. This is our unit circle, and on unit circle, any point, suppose this point coordinate is x comma y. X comma y means here we can put any value. X comma y, in this x comma y we can put any value we like. So and the exact reflection of this point is here, which is x comma minus y. So what is the value of sine and cosine here? You see, this first value is, we know that from the unit circle always first value is cos, and the second value is sine. This value is sine, always, and this value is cos, this value is sine. And this, you know that our rotation is always anti-clockwise, so this is the theta, and if we go clockwise, that means angle is now negative. So if you come here, that means it is now negative theta. For negative theta, you actually get, for cosine you get positive, and for sine you get negative value of y. In this quadrant, our first value, x value is positive and y value is negative. That means, it means what? It means our sine theta, cos theta value will be positive. Answer will be positive for cos theta, any value, any angle. For sine theta, any angle, it will be negative. And we can simplify it. We can say that okay, we can say that Okay, if I go cos of minus theta, then our answer will be positive. That means we will simply get the cos theta. We will get the cos theta. Why simply same value? Because you see same x and then x. This is exactly reflection of the point. So the value remains the same. Value remains the same. And for sine, you see the value, the sign of this point, actually this y value, the sign changes. So sign changes. That's why sine of minus theta, if you come back, then basically you will get the minus sine theta. Whatever the answer you get, you will get a negative sign before it. You will get a negative sign before it. And the reason is you come to this quadrant. Also, you can use the quadrant idea. Also, this is the fourth quadrant. In this fourth quadrant, from our concept, this is all positive, this is sine positive, this is tan positive, this is cos positive. That means only cos is positive in that quadrant and everything else is negative. So that's why only cos is positive. Since cos is positive, sec also positive, and everything else is negative. You can see this is negative, this is also negative. And everything else is negative other than cos. So sec also. Cos and sec is reciprocal to each other, so their sign will remain same. So how it helps? Even odd properties. How? So we are saying that. Then we will say that our cos function. This is the cos theta. And sec theta. You see what is the relationship here? If you look at this function, you will notice that here, if you give negative, your answer becomes positive. So which function does this same thing? See, this function. If you give negative inside this x, because this is whole square, so the answer will be positive actually. Instead of x, if you write minus x, then minus x whole square, your answer comes positive. Answer is again x squared. That means this cos, it is an even function. This is an even function. And the other two box, this box and this box, they are odd function. I have their picture also. In the next page you will see the picture, and in the picture also you will see they are matching. Before we go to picture, let's try to see the application where we can use this kind of concept. Suppose a math is given tan of minus pi by 4. How can I solve it? Since we know that for the tan function, minus theta means actually minus tan theta, so we can write it, this thing says tan pi by 4. That means this sign will come outside the bracket. This equals to minus, and tan pi by 4. Pi by 4 means 45 degree. Tan 45 degree means 1. So we can write here 1. That means answer is minus 1. So simply this minus, let me write it in another color. This minus here is just simply that minus here. And tan 45 equal to 1. Tan 45 equals to 1. Now this one, for this one, this is sine minus, so same. For negative, we just give the negative outside the bracket. Then because the negative will come outside, then sine 3 pi by 2. So sine 3 pi by 2 equals to what? Sine 3 pi by 2, sine, this value is actually sine of, this value is here. And this is 0 comma minus 1. And if we consider it, then we get sine 3 pi by 2 means 270 degree. For 270 degree, sine value is negative. So minus, let me find it out from here, sine so this value is, yeah, see, I will show you the answer from here also. So we have this negative, then sine 3 pi by 2, this is also negative value. See, this is negative value. So we write here minus 1, and ultimately we get a plus 1 here. Ultimately we get a plus 1, and you will see that in the here also. This is another way to solve. Since calculator actually knows this, I have written here minus 3 pi means 180 divided by 2, just to yeah. So this is how we get them. And if there is some cos function, suppose cos of anything, cos function will give us the positive answer. Suppose cos of minus, cos of minus, suppose pi by 3, pi by 6, pi by 3. Let's give pi by 3. So cos of minus pi by 3, if there is some math like this, then it will this will make it positive. So automatically it is positive by using the cosine rule. We will first make it positive, then it is just simply cos pi by 3, and then by the value of cos pi by 3 is cos pi by 3 means cos 3, so 60 degree. Cos 60 degree means 1 by 2, 1 by 2. So this is 1 by 2. That is the solution. Just even odd properties helps us to eliminate this negative sign within the angle. This is how it helps us, this even odd properties. Then we have their graph. You will see from their graph also, you will see that they are matching. This is the these are all their graph. So this is the sine function. You see sine graph is actually symmetric with respect to origin, and tan graph is also symmetric with respect to origin. Our origin is here, so just we have to consider the first part of the graph, because for this graph, and there will be some more graphs this side. So you see this is the for origin symmetry. This is this one and this one. Corner will match for origin symmetry. This one, this side, and this side. So that means sine function and tan function, they are actually odd function. And this one, see, y symmetry, this is symmetry with respect to y. That means this is even function. That means it is even function. So from the graph also we actually understand what type of function this one is. This is another task for us to do. This is to find out the exact values of different trigonometric functions. So we have 6 trigonometric functions. For that 6 trigonometric functions, one of them is given, which is tan theta equals to 1 by 2, and they said that sine theta is less than 0. We have to find out the remaining 5 trigonometric functions of theta. So how can we find out? And also we said that solution 1, this is first solution, is unit circle. So if you draw some unit circle, just roughly if we draw a unit circle, this is actually our last topic, but we have 2 different methods to discuss, so this is a big topic for this lesson as well. How can we, what we understand from this? See, this is the unit circle. First of all, this is that tan theta is 1 by 2, and then sine theta is less than 0. So sine theta is less than 0 means sine theta is negative. In which quadrant sine theta is negative and tan theta is positive? You will notice that this is actually in this quadrant. In this quadrant, sine theta is negative and tan theta is positive. That means they are talking about something here. They are talking about something here. And you know that tan theta means sine theta divided by cos theta. Sine theta divided by cos theta. From our fundamental identities, cos theta. Sine theta divided by cos theta. That means, and also you know that cos theta is basically the value of x. So this is the value of x. Cos theta is the value of x on the unit circle, and sine theta is the value of y on the unit circle. So now we know a couple of things about this figure. First thing, we know that the value is somewhat here. In this box, anywhere you can put this point, in this box, in this quadrant. And then you know that if you draw some line here, you know that on that line, this line, this is the value of we can write from here directly. So our x value is 2. X value is 2 since this is the value of cos. So that means 2 is here. But in this quadrant everything is negative. That means it will be minus 2. And our y value is 1. So that means it will be minus 1. So the coordinate of this point is minus 1, minus 2, minus 1. How do we know that? We know it from this given value. Tan theta equals to sine divided by cos. Sine means our always, for the sine theta, always this is the value of sine theta is the represent, as you know from our unit circle. From that unit circle, our second value is the sine, first value is the cos, first value is the x. So that means x is here, 2 is here. Now if you draw some line here which will represent the hypotenuse actually, and this is the angle they are talking about. So this value, based on this figure, you can see this value is, this minus 2 is the x value, and this minus 1 is the y value. So minus 1 is here, minus 2 is here. Since now you know this is minus 2 and this is minus 1, you can actually find out what is the value of the hypotenuse. This value, because now you know that this is 90 degree. If this is 90 degree, then what is the value of hypotenuse? How can you know it? How do you know it? We know it by using x square plus y square. So we can suppose this is x. So we know that x square will be equals to, let's not give here x because we know that this is this side is x. So let's give here something like c or m, n, something different. So c square equals to minus 2 whole square plus minus 1 whole square. Pythagorean theorem. This is the Pythagorean theorem. And this is 4. This is plus 1. That means plus 5. So c equals to square root of this plus minus square root of this. So this value is our, we will have 5 here. So that means root 5. So we will have root 5 here, plus minus root 5 here. For this plus minus, now you see the same calculation actually we have shown here in the next page. So the same calculation we have shown here. This is our whole calculation here. This exact things, x square plus y square, that means x means minus 2. If we draw this line, this is the minus 2, this is minus 1. So we know that x square plus y square equals to this. Then we know that the length of this side is root 5. So this is root 5. This is the length of this side. This is the root 5. And once you know that, actually, we can find out the other things. We can find out sine theta, cos theta, tan theta, whatever we want. Now we can find out, because it is a right angle triangle, and the theta value of theta is here. Minus 2 is, this is the adjacent is minus 2, opposite is minus 1, and hypotenuse is root 5. Now you can actually ask me one question, sir. Our value in the other page, when you have done the calculation, the value was plus minus root 5, but you are just writing here plus root 5. Why is that so? The reason is there is 2 ways to understand it. One way is you can look at this quadrant. In this quadrant, actually, you see there is a minus here, there is a minus here. If both is minus, then this side is, then this will be positive. And if either of them, if one of them is negative, then actually this value comes. Then we can look for positive, negative, and then this can come negative. From the, this slope, the idea of slope. You know that idea of slope, rise over run. That thing also helps us to understand that concept. So sine theta equals to, now sine theta equals to what? Sine theta means our sine SOHCAHTOA, O by opposite by SOH, O by H. So O means opposite means minus 1, H is root 5, so we can just write it. Cos means CAHTOA, CAH, so adjacent by opposite. I mean, without just looking, this is the radius. Radius means the radius of the circle. Okay, radius is radius of the circle. So yeah, we can actually use that. Then we can take this A divided by H. So we can just find the other values. Tan theta value is tan theta is 3, so a divided by h, a means adjacent, divided by so TOA. Opposite divided by adjacent. So opposite is -1, adjacent is -2. So -1 divided by -2 means 1/2. So this is the tan theta value. And tan theta value, we can also see it from here. This is the tan theta value. So cot theta value will be 2, just because this is the other way we can do it. So this is how by using unit circle we can find out the different trigonometric functions, other trigonometric functions values. We can find it out. And wherever it is, we just have to find out, like, okay, in which quadrant our angle is falling, then how to do the calculations. And if we have that right angle and adjacent and opposite, hypotenuse, adjacent, opposite and hypotenuse of that, then actually we can do all the calculations to find out the remaining values. Okay, so this is the unit circle approach. Then we have trigonometric identities. Same math. For the same math, tan theta equals to 1/2. Sine theta is less than 0. That means sine theta is negative. So for the same math, how can we use trigonometric identities? These are the fundamental identities. How can we use this to find out the solutions without using the unit circle, without using the circle? By the way, that is not unit. That is actually circle, not unit circle, since the radius is not 1. If the radius is 1, then it is unit. So that's just a circle. So this is tan theta. Tan theta equals to half is given. Now from our, how do we know? Suppose you can ask, how do we know that we have to use this formula? So see, we have 3 formulas here. This is sine square plus cos square equal to 1. Tan square plus 1 equal to sec square theta. So this formula is related to tan. That's why we have to use this formula, tan, because tan value is given. That's why. So if we use this formula, then actually sec value we will get. So sec theta value we will get sec theta value. We will get the sec theta value, and you can see this is 5/4. So sec theta equals to plus minus root 5/4. Now why we are taking only the negative value of sec theta? Because you know that due to this condition, we know that in the third quadrant in this box, sec theta is negative. That's why we are just taking it negative. Because first of all, we have to identify in which box this question falls, this condition falls, in which box, in which quadrant. So we know that this is in our third quadrant, and in our third quadrant, our sec theta is positive. Sec theta, cos theta, tan theta, sine, cos, cosec, sec, all of them negative here. Only tan and cot is positive here in this box. So sec theta, from this thing we have to just take the negative value. That's why this negative value is taken here. This is how we know that. Negative value you have to take, not the positive one. So now you have sec theta value, and also in the question it is given tan theta value. So by using these formulas here, actually you can find out all of them, the remaining all of them. We can find out the remaining all of them. Okay, so how can we find it out? We can find it out by using, you can say this is sec theta value, so sec theta equals to minus root 5/2. So now you know how to find out the cos theta, because cos theta will be same sign, but just this will be reciprocal, so 2/√5, or so let me find it out here. So cos theta will be, minus will remain there, of course, then 2/√5. So downside we cannot write root, so it will be minus 2√5 divided by 5 this way. Now you have cos theta value, sec theta value, and tan theta value. So we can use this formula to find out the sine theta, because tan theta and cos theta value we have, so we can find out the sine theta. And this way, by using these formulas, actually this is very easy to find out now other things, and which is actually here. You can have a look, and then you will see tan theta by using this formula. Tan theta equal to sine by cos. That means sine equals to tan into cos, and tan value and cos value we already have. We just multiplied and we have the answer. Okay. and then cos theta equal to 1 by sec theta, so we get the cos theta value minus 2 root 5 by 5. Cot theta is the opposite reciprocal of tan theta, so we can find out this. Okay, this is our last topic, and I will agree with you if you say this kind of maths are a little bit lengthier. Actually, these are the lengthiest math in this section 6.3. So it may take a little time for you all to get expert on this, but trust me, these are not difficult. And also we will discuss this maths during the class time. Also, you can ask if you have questions. These are the summary of what we did. There is two methods. One is using a circle of radius r and using the identities. So there is two methods to solve them. From the book I have taken this, of course. These are taken from the book. So that's all for today's class. These are your practice work. You can try to practice. Some maths are from even odd properties from here. Some maths are from periodic properties from here, and some maths are from finding the exact values of trigonometric functions for one trigonometric function given and another concept to find out the quadrant given, just like the math we have solved. Okay, so that's all for today. Thank you all. Thank you very much, and have a good day. See you all in the class. Bye bye.